Good morning, dear children of Standard 8. Today, let's unravel the mystery behind the chemistry. To start off with, we have to first understand the language in which we can talk chemicals and their reactions. That is why we are going to study the chapter Language of Chemistry. Chemistry is a very intriguing subject, definitely tickling your minds, especially when it comes to reactions and understanding the complexity behind the reactions. What makes it more interesting is that we can understand these reactions with a very simple things such as symbols and valencies. Let us understand what do I mean by symbol and valency. Symbol is a shorthand representation of an atom, and therefore it can be used to decipher different chemicals and their names. For example, we have a list of elements and their symbols. You can see hydrogen can be represented as capital H, carbon as capital C. Chlorine, on the contrary, is represented as capital C followed by a small l. Now, why this happens is because of the similar chemical names. You can see it starts with carbon starts with C, and even chlorine starts with C. Similarly, calcium also starts with C, so we need a different method of writing the name. So we write capital C and a small a. Now, some of the names being the symbols being repeated, we need to have a different symbol or symbol representation. That's why we go for the Latin name and the derivatives. Sodium is represented as Na, which is other words named as natrium. Potassium as K, kalium. Argon as Ar. Silver as Ag. After symbols, we need to understand the value of valency. Valency, which is otherwise called as the combining capacity of an atom of an element. That means, in other words, we can define valency as the number of hydrogen atoms that can combine with an element to form the respective hydrides. Let us understand this definition, the second definition. If we want to find out the valency of carbon, which is 4, how can I be so sure that carbon's valency is 4? Look at this formula, CH4. That is, carbon is combined with 4 atoms of hydrogen. Since the 4 atoms of hydrogen is combined with carbon, therefore its valency becomes 4. You can also see the valency of chlorine, Cl, which is 1. Why? Because one hydrogen atom combines with only 1 chlorine. Similarly, we can also tell the valency of nitrogen being 3 because 3 hydrogen atoms combine with with 1 atom of nitrogen to form ammonia. It is but a strange observation seen in case of some elements. Elements such as copper, iron, tin, etc., which shows not just one valency like the other elements, it also have got multiple valencies. Variable valency is a tendency of an element to have more than one valency. Example, copper has got valency 1 and 2. Therefore, we can represent copper having valency 1 as copper 1 or cuprous. Copper having the valency 2 can be represented as copper 2, Roman numeral 2, or cupric. Similarly, we can have iron which have valency 2 and 3. Iron having valency 2 is called as iron 2 or ferrocide. Iron having valency 3 is called as iron 3 or ferric iron. Now let us understand what is the reason behind having variable valency. This is a structure of an atom having a nucleus and multiple shell. The last shell of an atom is called as the valence shell. The second last shell, on the contrary, is called as a penultimate shell. It is an observation that during chemical reactions, the element might lose or gain electron from the valence shell. But under adverse conditions, an element can lose electrons not only from its valence shell but also from its penultimate shell. Such elements will show variable valency. Another interesting term that we come across in case of chemicals are ions. Now, what are ions? These are the charged particles formed by either loss or gain of electrons from their valence shell. Whose valence shell? The element's valence shell are called as ions. Ions can be of two types. It can be positive ion, it can be a negative ion. A positive ion is always called as cation. A negative ion is always called as an anion. Who forms positive ion? A metal. Metal generally forms positive ion. Metals may lose one electron to form unipositive cation. You can see the symbol. A metal can lose two electrons to form dipositive cation, represented as capital M, 2 plus. And tripositive ions or cations are formed when metal loses 3 electrons. The negative sign over here indicates the loss of electrons. We have a number of examples which relates to it. For example, sodium ion Na plus, potassium ion K plus. We have divalent cations such as calcium Ca2 plus, magnesium as Mg2 plus. Similarly, we also have trivalent cations such as aluminium Al3 plus. Similarly, as we have negative ions, we also have positive ion, we have negative ions. Negative ions are called as anions and formed by non-metals. Uni-negative anions are the one when an electron is gained. The plus sign over here indicates gain of electrons to form a uni-negative ion. When they gain 2 electrons, di-negative anion. Tri-negative is when they gain 3 electrons. Let us take for example chlorine, Cl minus, F minus, fluorine. In case of divalent, we have got oxygen, O2 minus. In case of tri-negative, we have got nitrogen, N3 minus, or this is also called as nitrite. When we learn about radicals, we also need to speak about radicals. Radicals are those molecules of the compounds which may possess positive or a negative charge. Example is NH4 plus. NH4 plus is also called as ammonium ion, and it's the only positively charged radical. Sulfate ions, SO4 2 minus, will possess minus 2 charge. Dichromate possesses 2 minus again. Nitrate possesses a single negative charge. This is also nitrite. This is a symbol for nitrite, NO2 minus. So these are termed as radicals. Once we have understood the terms like symbols, valencies, ions and radicals, we now can move forward to writing of the chemical formula. A chemical formula can be written by following these ideas. Firstly, we have to write down the name of the chemicals. For example, we have written over here sodium chloride. See, I have kept a small space between them so that the two ions can be distinguished from each other. Sodium is a positively charged ion and chloride is a negatively charged ion. Let us first write down the symbol of these two ions. Sodium Na and chlorine Cl. Na and Cl are the symbols. What about the valencies? They possess both 1 valency. Since we cannot further simplify the ratio, that is 1:1, it is already in the simplified form, we can easily cross multiply the valencies, and therefore we get the formula NaCl. Magnesium oxide is written by the same method. First we write down the name, then the symbols. You can see magnesium MgO and the valency 2 and 2. Remember, these are the valencies. Magnesium has got 2 and oxygen also has 2. In that sense, the valencies in these two valencies can be easily simplified. 2 is to 2 can also be written as 1 is to 1. Since the highest common factor is 2, and if we divide both by 2, we get what? 1 is to 1. Now, once the ratio is in a simplest form, we can easily cross multiply it to write down the chemical formula MgO. Let's go to another example. Sodium sulfate. In case of sodium sulfate, what do we see is sodium possesses valency 1 and sulfate SO4. Remember, mind it, SO4 as a whole is the symbol, has a valency 2. In this sense, 1 is to 2 is already in the simplest form. So therefore, we don't have to simplify it further, and hence we can easily cross multiply it. And how to write down now? Na is multiplied to 2, so Na2. SO4 is multiplied to 1, so we don't require to write down 1. So SO4. So the formula becomes Na2SO4. The last one that I want to talk about in terms of writing chemical formula indicates aluminium sulfate, AlSO4. Aluminium has a valency 3 and sulfate has a valency 2. These two are also in the simplest form, so we do not have to make it in a simpler form. Hence, we can directly cross multiply it. When I do so, remember 2 is multiplied to the whole atom of aluminium, Al, so I write down Al2. But when I talk about 3 multiplied to sulfate SO4, we have to understand that 3 is multiplied to all the elements in the SO4. So I put the brackets or braces, and then I multiply it with the whole radical, that is 3. So remember, in such cases, we always put brackets around. So children, I hope you have understood the method of writing chemical formula. In the next session, I will be teaching you how to write a chemical equations and how to balance it. Thank you.